Think about it for a second. In this digital world, where everything's online, how do we actually know if what we're interacting with is real, authentic, in the right order?
Right.
Especially when you've got systems without one central boss, no single authority. How do you get everyone to trust the sequence of events?
That really is the crux of the issue, isn't it? When you take away those traditional middlemen, you need something else. A different method to create a shared history, one that everyone agrees on, and crucially, one that can't be changed later.
Exactly. And that fundamental challenge is what we're really digging into today. We've got some, honestly, quite fascinating material here on the ACRE Consensus Service, ACS for short. And our goal, our mission for this deep dive is pretty straightforward. Figure out what ACS actually is, how it functions, the nuts and bolts, and maybe most importantly, why it could be, well, a pretty big deal for lots of different online activities and applications.
Yeah, understanding its potential impact.
We're looking at, its basic purpose, the advantages it supposedly offers, a bit of the tech behind it, its key features, and some potential uses. Think of this as your, express lane to getting up to speed on ACS.
Precisely. And by the end of this, you should have a really solid understanding of what ACS offers for creating that trusted flow of information, especially in these decentralized setups.
Okay, perfect. So let's start high level, big picture first. What is the AERE Consensus Service? Layman's terms.
Okay. So at its core, ACS is a service running on what's called the AERE Network. You can think of the AERE Network as the base layer, the infrastructure. It's a distributed network that allows services like ACS to function.
Right, the foundation.
Exactly. And what ACS does on that foundation is provide a transparent, trustworthy way to order data. Think of it like a highly reliable digital timestamping service, but also an ordering service that many different applications can tap into.
So it stamps the time and puts things in sequence.
Yes. Its primary function is to create a verifiable log, a record of when things happen and in exactly what sequence. And that becomes incredibly valuable for these decentralized apps, where, as you said, there's no single central authority keeping the master list.
Got it. So it's about getting everyone on the same page about what happened when, without needing that central controller to dictate it.
You've nailed it. And this ability, this fundamental capacity to create a shared or agreed-upon history, well, that unlocks quite a few interesting possibilities. And the information we have really highlights several key benefits.
Okay, let's dive into those benefits then. The first one that really catches the eye is high performance, speed. That's always huge in the digital realm.
Oh, absolutely. The documentation, it mentions ACS can handle thousands of messages per second.
Yeah.
Now, just imagine applications that need that kind of throughput. Think high-frequency trading or maybe large IoT networks spitting out data constantly.
Huge volumes.
But what's key, and they emphasize this, is that the speed isn't just raw processing power. It's built on fair ordering and verifiable timestamps. So the performance doesn't come at the cost of integrity or trust. It's fast and reliable ordering.
That's a critical distinction. Speed alone isn't enough if you can't trust the result. Okay, next up, simplified integration. Sounds promising for the people actually building things with this.
It really does. The focus here seems to be on making it, well, not a nightmare for developers to use. They talk about easy-to-use APIs and SDKs, aiming for rapid implementation.
APIs and SDKs,
right?
The building blocks for developers.
Exactly. And they even list specific common programming languages like JavaScript, Java, Go. So the goal seems to be lowering that barrier to entry, making it easier for developers to actually plug ACS into whatever they're building.
So powerful and relatively easy to work with. That's a good combo. Now, thinking about bigger players, the next benefit is enterprise ready. What does that mean in this context?
This points towards features needed by, larger organizations, businesses operating in maybe more complex, often regulated fields. Things like access controls and the ability to create private topics.
Okay, explain private topics.
Imagine a company needing to share specific transaction data, but only with their finance department and auditors, not publicly. Private topics let them create these restricted channels. And the mention of compliance features also suggests they're thinking about how businesses can use this while still meeting legal and regulatory obligations.
Right, so it's designed with business needs and rules in mind, not just open for all systems. It also mentions developer-friendly. How is that different from simplified integration? It's just repeating.
There's definitely some overlap, yeah. But developer-friendly seems a bit broader. It includes those easy APIs and SDKs we mentioned, but it also explicitly calls out comprehensive documentation and support.
Oh, okay. The surrounding help.
Right. It's not just about making the initial connection easy, but also providing the resources, the manuals, the help desks, whatever that developers need as they continue to build and maintain their applications.
Makes sense. Good docs and support can be lifesavers. And the last benefit here is cost-effective. Always important.
Always. And the model they describe is pay only for the messages you submit. That sounds pretty appealing.
Pay as you go, essentially.
Exactly. The idea is you're not paying for idle time or unused capacity just for what you actually use the service for. This, they claim, leads to predictable low fees. And they specifically contrast this with other blockchain platforms where costs can sometimes be, well, unpredictable or significantly higher.
Okay, that's a strong list of potential upsides. Performance, ease of use, enterprise features, developer support, and cost. But let's get into the how. How does it actually work? The info lays out 4 steps, starting with create a topic. What exactly is a consensus topic?
Right, so think of a consensus topic as like a dedicated lane or channel specifically for a certain type of related information. The documentation uses that channel for related messages, analogy.
Like a specific channel on a streaming service, maybe?
Sort of, yeah. And what's neat is the flexibility. You can have public topics, maybe like a public broadcast channel anyone can potentially listen to, or you can set up private topics with access controls. That's more like a restricted members-only channel where only authorized applications or users can submit or read messages. If we use that AERE Network highway analogy again, topics are like dedicated lanes for specific kinds of traffic.
Gotcha. Dedicated lanes for data. Okay. Step 2, submit messages. Seems straightforward enough.
It pretty much is. Once your channel, your topic is set up, and assuming your application has permission, it can start sending its data packaged as messages into that specific topic.
And the examples are quite varied.
They are. Financial transactions, supply chain events, even social media posts. It shows the range, basically. Any kind of event or data point that needs reliable ordering could potentially be submitted.
Okay, data flows into the channels. Then we hit the really critical part, network consensus. How does the AERE network actually agree on the order and timing? This feels like the core mechanism.
It absolutely is. This is where the decentralized trust gets built. Now, the material doesn't go deep into the specific consensus algorithm. They use the exact rules for agreement.
Like the underlying math and protocol.
Right. But the key takeaway is that the nodes, the computers making up the AERE network, collectively reach consensus on the exact order and timing of every message submitted to a topic. This process is what guarantees that the resulting sequence is tamper-proof. Everyone participating ends up with the same cryptographically secured history agreed upon by the network, not dictated by one party.
So the network itself, through these rules, collectively establishes the what happened when truth and makes it permanent. Okay? And the last step, verify and subscribe. How do applications actually use this ordered data?
This is how they consume and trust the output. Applications can subscribe to topics they care about, essentially telling the network, send me the messages from this channel.
Like tuning into that channel.
Exactly. But crucially, they don't just get the messages, they can also verify their order and authenticity using cryptographic proofs that the network provides alongside the data. Think of these proofs like a digital seal or signature confirming mathematically that this message is part of the official sequence in this specific order and hasn't been messed with.
Wow. Okay, so you don't just receive it, you get mathematical proof that it's the legitimate, ordered data. That's a huge layer of trust.
It really is. It underpins the whole value proposition.
Now, the information also asks, why choose AERE Consensus Service? And lists some key features. Are these just repeating the benefits we talked about, or is there more detail here?
There's definitely overlap, you're right. It reinforces the main points. But the features section often frames them slightly differently, maybe tying them more directly to how the service achieves the benefit. For instance, tamper-proof logging.
Right, we heard about the immutable log.
Yes, but here it explicitly links that outcome, the immutable log, to how it's achieved, through the fair, transparent ordering and timestamps verified by the AERE network. It connects the feature directly back to the consensus mechanism.
Ah, I see. It clarifies the why behind the what. High throughput is listed again, too.
Yep, and here it specifically links it to high-volume applications requiring consensus. It emphasizes that this speed is designed for situations where you need both volume and that verifiable agreement.
Makes sense. Then there's fair consensus. What's the key point there?
The crucial thing about fair consensus is stopping front-running or manipulation by network participants. In systems where order matters like finance, you absolutely need to prevent anyone from unfairly jumping the queue or manipulating the sequence for their own benefit. This feature tackles that head-on.
Right, maintaining a level playing field. Developer-friendly also reappears, but this time it specifically lists the languages: JavaScript, Java, Go.
Exactly. So it moves from the general concept of being easy to use to giving concrete examples of the tools developers can actually work with, reinforces the accessibility point.
And cost-effective is back, again hitting that pay only for what you submit angle, and making that direct comparison fees are substantially lower than other blockchains. That's a bold claim.
It is a bold claim and potentially a very significant advantage, especially, as we said, for applications pushing a lot of messages through the system. It could make certain decentralized solutions much more economically viable.
And lastly, enterprise-ready as a feature. Again, focusing on governance and compliance and that ability to create private topics.
Precisely. It hammers home the point that this isn't just a cool tech experiment. It's being built with the practical needs, the rules, the regulations that businesses often operate under firmly in mind.
Okay, this is making a lot more sense now. We've got the what, the why, the how, the features. Let's talk about the so what. Where does this actually get used? What are some real-world applications or common use cases for ACS?
Yeah, this is where it gets tangible. The info gives several good examples. First up, decentralized messaging.
Secure chats, basically.
Secure chats, but with a twist. Imagine messaging platforms where the entire conversation history is guaranteed to be tamper-proof. And the order of messages who said what, when, is cryptographically certain. Think about the implications for compliance, for legal discovery, for auditing conversations in regulated industries.
Oh, wow. Yeah, for financial advisors, legal teams, that could be huge.
Okay.
What else?
Supply chain tracking. This is another big one. Using ACS, you could build a system where every step a product takes from raw material source to final delivery is recorded immutably.
Creating a verifiable chain of custody.
Exactly. A verifiable audit trail. This injects a massive amount of transparency and accountability. Everyone involved can trust the record of where something came from, where it's been. Think about tracking high-value goods, pharmaceuticals, food safety.
Yeah, proving authenticity and tracking history in complex supply chains. That has massive potential. Any other examples?
Yes. Market data feeds. So publishing financial data like stock prices or other market information, ACS could ensure these feeds are fair, tamper-proof, and verifiable by anyone. It helps guarantee the integrity of the market information everyone relies on.
Better trust in financial data feeds. That seems vital. And the last one mentioned is compliance and auditing.
Right, and this kind of pulls everything together. Because ACS creates these immutable event logs, it essentially provides perfect, unalterable evidence of what happened and when. This could dramatically simplify audits, make it easier to prove compliance with regulations, and potentially reduce disputes because the record is clear and trusted.
So it seems the applications are pretty diverse. Secure messaging, supply chains, financial data, general auditing. It's quite broad.
It really is. And you can see the common thread, right? Anytime you need a trustworthy, ordered sequence of events in a situation where multiple parties are involved, especially without a central controller, a service like this becomes incredibly valuable. As more things move towards decentralized models, that fundamental need for trust and order just grows.
Okay, let's try to boil this down. If someone asks you for the elevator pitch on AERE Consensus Service, what's the core message?
I'd say the core idea is this. ACS provides a reliable, efficient way to establish trust and verifiable order in decentralized systems. It uses network consensus to deliver benefits like high speed, ease of use for developers, features that businesses need, and it aims to be cost-effective. At the end of the day, it's about building a trusted foundation, a tamper-proof, time-ordered record that decentralized applications can rely on.
A foundation of trust and order for decentralized systems. That makes sense. So thinking about this growing need for trust, in our digital lives, it does make you wonder. We've talked about messaging, supply chains, finance, but what other areas, maybe ones we haven't even thought of, could really benefit from having this kind of guaranteed, transparent, verifiable ordering of information? It feels like there could be so much more.
That's a great question to leave people with. Think about voting systems, perhaps, or managing digital identities, or even scientific research data. Anywhere where the sequence of events or the integrity of a log over time is absolutely critical and potentially contentious. The potential applications for this kind of foundational trust layer. Yeah, we might just be scratching the surface right now.